Electrical charge and Coulomb's law. After watching this video, you should be able to list the charge of a proton, neutron, and electron in the units of coulombs. And second, use Coulomb's law to calculate the electrical force between any two charges. Let's look first at the charge of protons, neutrons, and electrons. These charges were determined experimentally by many different physicists, including Robert Millikan. The units for the charge on any subatomic particle is called the Coulomb, named after Sir Charles Augustin Coulomb. Notice that the charge for the proton and the electron are identical, but different signs, because electron is negative and a proton is positive. So electron and proton has the same magnitude of charge at 1.60 times 10 to the negative 19th coulombs. However, the electron again is negative, proton is positive. Neutrons are neutral like Switzerland, so neutrons have no charge. I also listed for you the masses of each of these different subatomic particles in kilograms instead of atomic mass units. So you can clearly see that, once again, the proton and neutron are virtually the same size, and the electron is considerably smaller. Please copy down these literature values into your notebooks. So we are already on to Coulomb's law. So Sir Charles Augustin Coulomb discovered that the closer two charges are to each other, the stronger the attractive or repulsive forces between those charges. So think about two magnets. If you point the positive end of one magnet to the negative end of another magnet, you will feel an attractive force. The closer you bring those magnets together, the stronger the force feels. Same with two positive ends of a magnet. If you bring two positive ends of a magnet together, as they are drawn closer together, you feel that force between the positive ends grow stronger, and that's a repulsive force. Sir Charles Augustin Coulomb discovered that the force exerted between two particle charges is inversely proportional to the square of the distances. Let's take a look at what that equation will look like. So here is Coulomb's law. The electrical force between any two charged particles equals Coulomb's constant, which is 8.99 times 10 to the 9th newtons meters squared per coulomb squared, or we can round this up to 9 times 10 to the 9th newtons meters squared per coulomb squared, times the charge on the first particle times the charge on the second particle, all divided by the radius squared. So again, Coulomb's constant, 8.99 times 10 to the 9th, is a value that should be written down into your notebooks, as well as this equation, because this is the important equation to be used on the test next week. Let's look to see how Coulomb's law will be used in an example problem. Two spheres have identical charges that are 75 centimeters apart. The force between them is positive 0.3 newtons. What is the magnitude of the charge on the sphere? So let's fill this out. So we've got Coulomb's law, force electric, equals Coulomb's constant times charge on one, charge on the second, all divided by radius squared. My goal is to find these two charges. And I know, because the problem told me so, that Q1 is equal to Q2. So I can rewrite this as force electric equals K sub C Q squared over R squared. And again, I can make that relationship because Q1 is equal to Q2. I'm now going to rearrange this equation to isolate Q. So I can say force electric times r squared, all divided by Coulomb's constant, equals q squared. Then what I can go ahead and do is I can square root both sides. So I'll be left with force electric, radius squared, all divided by kc equals q. I'm now ready to plug in my values. All right, we're going to plug in the values of my force electric, which is going to be the 0.3. Now the radius is in centimeters, so it must be, as always, changed to meters. So 0.75 squared, dividing this centimeters by 100. And then I'm just going to round Coulomb's constant to 9 times 10 to the 9th equals q. And when I solve here, I should find that the charge on each of these particles should be 4.3 times 10 to the negative 6 coulombs. And checking significant figures. Up in my original problem, I have 2. So I have 2 down in the bottom here. So 4.3 times 10 to the negative 6 coulombs per charge. And that's all there is to it for Coulomb's law. One important fact about Coulomb's law is Coulomb's law allows you to calculate the magnitude of the force between two charged objects. Magnitude is scalar. That means it does not have positive or negative signs. So you can ignore the positive and negative signs on the Q values if they are given. However, like in our previous problem, we see that the charge or the force between both the charges were positive. That means that it was probably an attractive force because you have a negative positive charge being where those two charges are being attracted to each other. You are now ready to do page 566, numbers 1 through 3. These are simple Coulomb's law problems. However, if you would like to see what the challenge problem will be on the next test, keep watching this video. So warning, the information that you are about to see is for those of you who will be prepared to do the challenge problem for the test next week. I'm going to talk about the superposition principle, kind of like the superposition principle between waves. Superposition principle in terms of electrical charges means the total force on an object will be calculated from the vector sum of all the forces on that object. Yep, I said the magic word. I said vectors. So, let's see what an example problem like that would be. Thought I'd throw that in because the challenge problem involves vectors. So I know you're already moaning, whining, complaining, frowning. You love vectors. You only have hugs, smiles, and warm, fuzzy feelings towards vectors. I know that you really do. This example problem is on page 567 of your text. And I'm giving this to you in the video, but you can also look at it on that page. Use that example problem to solve for the final charge on Q3 from charge Q2 and Q1. You're going to have a challenge problem kind of like this one, not exactly like this one, but kind of like this one on the next test. So that's for people who would like to be a little bit challenged next week in the last week of school. That is the end. Thank you for watching all my videos this year, and good luck.